Hey everyone. Welcome to Scalekit's webinar on building for the agentic era. And we'll also see how to add authentication to your MCP servers. So today I'm excited to be here with all of you as we dive into one of the most important and emerging standards in the developer tooling ecosystem. So before we jump into the session, let me introduce our amazing speakers for today. Ravi, our co-founder at Scalekit, will be driving the discussion. He has an extensive background in product management at Freshworks, where he led the identity, authentication, and access management for over 2 million daily active users. Ravi brings deep expertise in developer platform architecture, and currently at Scalekit, he is building a modular platform for AI applications. We also have Akshay, who is a lead software engineer at Scalekit. He has spent the last several years building tech products at companies like Fidelity Investments and Freshworks. So let's get started.
Thanks, Amal, for the intro. Hey, thanks everyone for joining in. Again, I want to make sure this entire conversation is as useful as possible to all of you. So feel free to interrupt if you have any questions. If you want me to cover any certain topics that you're interested to, please feel free to send a message in the chat. We'll keep monitoring it and make sure that you take away something valuable by the end of this conversation. Having said that, let's get started. So we are a Scalekit. We are building modular authentication and authorization platform for AI applications. But before we get started with the actual agenda, I just want to understand how many of you have used any MCP servers. If you can just drop a quick note in Zoom chat, it'll be useful for us to know so that I know how to tailor this conversation to make sure that it's adjusted to your current understanding, right? If you have used any MCP servers, maybe Slacks or Stripes, or even maybe GitHub's MCP servers, etc., raise your hand or drop a message in Zoom chat. That'll be helpful. Okay, I see very little. Then is it safe to assume that you guys may not have built any MCP servers, but would like to know more about how MCP servers work? Why is that even interesting in the era of agentic applications and agentic access? Maybe we'll get there, and then maybe we'll introduce briefly about MCP architecture. At the end of the demo, we will show, at the end of this webinar, we'll show a quick demo of how can you add a secure authentication layer for your MCP servers before you build and release those MCP servers for your customers. Okay, let's get started. So if you take a trip down the memory lane, not so long ago, all of us developers were building applications, and we were just giving these applications to our customers as a kind of a black box. What I mean by black box is the customers are able to use these applications the way we built and developed and then offered to them. There is no way for them to make any modifications, even if they want to, add new features, or maybe even do simple bug fixes, customize the product to their use cases. What happened a few years down the line was this became a very big need, especially for enterprise customers who are buying the software. Software as it is built may not be tuned to their org workflows or processes. So they wanted a way to be able to customize the software to their specific needs and use cases. So developers started giving out APIs as a way for their customers to use the APIs and build any additional capabilities on top of that, or make any changes to the product the way it makes most sense for the customers or the buyers of this particular product. Now, if you look at the fundamental problem with this is APIs are meant to be used by developers with understanding of how to write code, how to read the API documentation, and how to best make use of these APIs to get the desired customization that they would need. But it is not really available for general users of any software. And that's where the whole agentic era leapfrogged the whole equation to say, hey, developers are building certain software, but any users, whether they know how to write code or not, should be able to leverage either take data out of those applications or make modifications or build their own custom workflows on top of the application interfaces that they're exposing to their customers. So the mental model that I would look at is applications in its original era, a couple of decades back, is more of black boxes that were built by developers and shared to the customers. And then the next layer came in APIs, where it offered some sort of customization, but again, it's still governed by what the developers expose to their customers, and it needs an engineering team at the customer side to be able to make use of these APIs and customize the product. And now the era is agentic access, or ability to use AI agents to customize the application behavior or modify the application's capabilities themselves. And when AI agents first came in, of course, if you look at the LLMs, right, they're fundamentally text in, text out. They predict the next word based on the training that they have and based on the memory and based on the context. But they didn't have a way to actually make remote API calls or remote procedural calls to access third-party applications and then do whatever they want. Now, every model came up with their own framework to give this, what I would say is agentic access to modify data or fetch data or modify the behavior of applications. Now, OpenAI came up with function calling as a framework, and Anthropic came up with their own model. But then eventually, when late last year, Anthropic releases a specification of how do you give power to agents to determine and execute how to make third-party application access or third-party application modification behavior, right? And that is what is model context protocol. So it quickly gained adoption across all developers and even across all model providers as a way to give LLMs the power to be able to access third-party applications, not even third-party applications. It can even be local file system or databases, or it can be anything, right? Anything via common protocol that every LLM model can understand to figure out how to make third-party access possible. Now, if you take a quick look at how does LLM even come into the whole picture of MCP, like I said earlier, LLM is just text in, text out, right? So they technically can't make any third-party applications. That's why there is this agentic code or any AI agents that you write will have to use the LLM's capability to determine how to or what tool to be called. Tool is nothing but think of it as a function call, right? LLM will help your AI agent to determine which function to be invoked or which method to be invoked or which tool to be executed to get the desired output based on the user's query or based on the context that the agent is operating in. So if you look at the fundamental simple workflow of a user using an AI agent to determine what's the weather like in a given city, the user would ask the agent, hey, what's the weather in Tokyo? The agent would use the LLM to say, hey, this is the user's query, and these are all the tools that I have in the context. Based on this user query and based on the tools that I have in context, LLM, can you tell me what to do next? The LLM would tell the agent or the MCP client, hey, for this user's query, and based on the tools that you have supplied me in the context, looks like this is the right tool to be executed to get the desired output for the user's query. And then agent would make an MCP tool call to the MCP server from which the tools are registered. And the MCP server would do whatever it needs to do and give the results back to MCP client or the agent. Agent would go back to LLM and say, hey, LLM, you asked me to make this tool call. I made the tool call. I got this response. Now, this was the user query. This is the tool call you asked me to do. And these are the results of the tool call. Now tell me what should be the next step. The LLM would process all that information. Either it'll ask the agent to make another tool call, depending on the response of the previous tool call and the user's query, or it'll say, all good, I have all the data that I need. This is the response. You can give it back to your user, right? So that is a workflow that generally behaves. So you need to think of 4 different actors in the whole workflow. One is the user whose problem that the agent is solving. So agent always needs to know who is the user, why are they asking me this query, so the agent can work effectively to resolve any user's query. And that agent should have access to MCP servers that have the actual tool execution capability and the underlying model which determines which tool call to be made without the developer having to pre-program the order of the tool execution or which tool to be called based on what the user query is. Everything is being leveraged by the LLM, right? So that's how it works. Now, let's go slightly deeper into what is MCP and what does the MCP architecture look like. In the overall picture of MCP itself, there are 4 players. One is MCP hosts. I think this is what you would pretty much be using day in, day out. Any application like a Claude desktop or Cursor or Windsurf or any of the custom AI agents that know how to work with or communicate with a pre-configured MCP server via a defined protocol. The protocol can be STDIO or HTTP, anything that both client and server can understand to communicate effectively is an MCP host. The MCP host is the one that has different clients that are establishing 1:1 relationship with different MCP servers that this MCP host is configured to work with. So this MCP client's responsibility is very, very simply put, it establish a connection with the MCP server and then says, I'm able to establish the connection. These are the capabilities of the MCP server, and this is how I would work with this particular MCP server. If the MCP host is configured to run with 5 different MCP servers, then technically there would be 5 different MCP clients that are operating within the boundaries of that MCP host itself. And the most important part of all this is the MCP server. The MCP servers are the one that knows how to establish connection with incoming MCP client requests and advertise their capabilities to the MCP clients, whoever they're asking, and also execute the tools based on the input parameters and the tool definitions that the clients are asking the MCP servers to execute. In this conversation, we are going to talk about some of the best practices of how to build MCP servers or how to add authentication layer for your MCP servers so that you can write effective MCP servers that can be used by any of your customers or any of the users that you want to give the MCP servers access to. Of course, the data sources, which is what the MCP servers are actually relying on to get the actual job done. These can be application APIs, these can be databases, these can be file sources, this can be anything that the MCP servers can effectively work with. For this particular conversation, let's go focus on MCP servers, how the protocol evolved over a period of time, and how the authentication itself was added to the MCP spec over a period of time, right? When MCP first came as a proposal from Anthropic team in late last year, the predominant protocol that was available was STDIO. What that means is an MCP host that has a bunch of MCP clients can only work with MCP servers that are running in the same device or same system via the STD in and STD out mechanism, right? But as you can imagine, you can't ask all your customers to download an installable and execute that installable because that installable could have unlimited permissions. They can wreak havoc. There's fundamentally a bunch of security issues that come with running local programs. So MCP evolved, the spec has evolved based MCP servers. What that means is just like how APIs work, maybe you would create an API server in your own system that you control, and then let any API client communicate to it over HTTP. MCP servers also brought similar paradigm, and they started adopting HTTP-based protocol, which is also effective because it is stateless. You can treat each request independent of the other requests, and you can scale infinitely, and you can adopt the same best practices that you would have adopted for API servers already. But when they actually introduced HTTP as a protocol for communication between MCP clients and MCP servers, they did not really think about auth. It's not that they didn't know, it's just that they realized that building or creating an auth layer for these MCP servers, it's not very straightforward. So the whole community went into a 4 or 5 month conversation, and then finally the community adopted OAuth 2.1 as a mandatory authorization protocol for secure communication exchange between MCP clients and remote MCP servers. Remote MCP servers are HTTP-based MCP servers, especially if that MCP server needs authentication to determine that MCP client communicate with that MCP server. If it can, what is the identity of the user on whose behalf that MCP client is working? So that MCP server can determine whether to accept the request, reject the request, or rate limit the request, or anything it wants to do based on the identity of the incoming user's request. So this is a very, very brief overview of how the MCP servers and the protocols have evolved over the last, 9 months. It's still very, very early days, and the spec is getting better, getting updated, getting improved really, really rapidly. And the whole community is taking up all these changes also at a very same pace. So this is great progress. This is great, but the fundamental question that a lot of people have reached out to us and asked us is, should I be building my own MCP server for my product, right? I think we have a very simple decision-making framework for you to decide whether you want to build an MCP server for your product. If you're building a product, B2C product, B2B product, doesn't matter. But I think one thing that you need to think about is, does your product offer APIs right now? Do your customers use your product outside the dashboard or outside the web application or outside the mobile application that you offer to them? Do they make any customizations? Do they make any changes? Do they extract any data out of your system? Or do they want to build their own custom workflows based on the APIs that you're offering? If yes, do you want to offer your customers agentic access to your product, which is beyond just your web applications and mobile applications and the APIs that you're offering to your customers? Do you also want your customers to be able to build agents so that they can build agentic workflows on top of your product capabilities. And if you are a dev tool product like Scalekit is, would you expect your customers to integrate your product's offerings right within their IDE? Like I was talking to an observability platform last week, and they've built their MCP server. What is working out great for them is their customers use the MCP server of this observability platform right within the IDE to debug, to troubleshoot, also to figure out any exceptions that are arising out of their local deployment and make code changes based on the exception logs. So you have to think of your own product and what sort of capabilities do you want to offer your customers so that your customers can derive much more value out of the offering that you're giving to them. And you can increase the product stickiness by offering some of these agentic access capabilities via the MCP server you build on top of your product. Let's say now you have decided to build this MCP server. Some of the best practices that we have learned by building a few MCP servers ourselves and then guiding some of our customers building their own MCP servers. First of all, don't think of building MCP server as an API wrapper on top of your existing APIs. I think that is the sure shot way of getting ugly results out of an MCP server. Just make sure that you're looking at, hey, what are the jobs that I would want an agent to be able to do autonomously? And then convert each of those jobs into a tool independently. And then make sure that there are as few interdependency between tools as possible. Some of the simplest examples that I'll tell you, I'm sure while you're building your product, you would give unique entities for every simple things like status. Instead of status being treated as a string, you may create a status ID, and then you would expect the status ID to be passed as part of parent entity like a ticket, for example. And then you ask your customers, hey, if you want me to create a ticket or update a ticket with an appropriate status, you have to pass the status ID in the API. But you don't want to build your tools like this. Ideally, you would want to make it as self-sufficient as possible. And you would want to make sure that the tool input would take status as a string, and then you would resolve internally how to convert the string into an appropriate status ID by yourself. You would want to make sure that you're not overloading the LLM with a lot of tools, and then you're asking the agent to work with LLM to figure out what tools to be used to solve a certain job and what is the order in which these tools need to be composed and executed. Because this adds to the overall context that the LLM is working with for every tool call that it is making. And once the context grows big, the LLMs are very easily confused and the output is not what you're expecting the customer to have. The second important point is all the good practices when it comes to scalability, reliability, security that you would use to employ for protecting your API servers would work and apply for the remote MCP servers also. Simple things like make sure that there is some sort of an authentication layer built on top of your MCP servers. Make sure that you have observability and monitoring baked in so that you know what sort of tools are being executed, what is the context in which they're being executed, what is a success, what is a failure, what is the order in which these tools are being called, so that you can constantly keep optimizing your tool definitions and tool descriptions and tool execution parameters, and make sure that you have a really good load balancer that is set up in front of your MCP servers so that you can scale horizontally and vertically whenever there is a need. I think the biggest mistake that people do when building their own MCP servers is error messages. This is often overlooked in the context of APIs. But in the context of APIs, it's still okay because it's a developer who is actually going through the documentation to understand what error message means what and then how to resolve those errors effectively. But in case of LLMs, you would want to give as much context as possible in the error messages itself so that based on the error messages, LLM can self-heal or determine what should be the appropriate tool that should have been used to solve this particular problem. Or it can also figure out what should be the next tool call based on the error message that is constructed. So the way you need to think of while building or designing your MCP servers is treat the customer of your MCP server like a super intelligent system, but it's also that gets very easily confused when you give very little or a lot of information. So you need to make sure that the information that is supplying to the LLM is just enough to get its job done, and then it'll actually do wonders. The next most important thing that I would want you to remember is make sure that whenever you're building or designing your MCP server, you're always thinking very, very defensively. When I mean by defensively, LLMs inadvertently are autonomous in nature. They are deciding what tool to be called, what tool to be selected, what tool to be implemented and executed based on the user's context and the tool definition that you are supplying it. So when they get confused, they may go into a loop of make a tool call 1. No, make a tool call 2. Now make a tool call 3. No, maybe I should have made a tool call 1. So they go into this loop of calling different tools, trying to execute the answer for the user's query. So you may want to look at your logs to determine, hey, what is the sequence of tool calls that are being made for a given context or for a given session? And based on that, constantly iterate your tool definitions and your tool descriptions and your tool execution logic itself so that you're optimizing for solving a particular problem for your customer via your MCP server. And then last, but the most important thing that I cannot stress enough is eval. Test your tool descriptions, the input schemas that you're offering as part of your MCP servers, and not just test with one model, but test with different models because you don't know what models that your customers are building their AI agents that are going to use this MCP. For example, a really smart model like maybe Gemini Flash 2.5 Pro that can determine the appropriate tool based on very limited tool description. But cheaper models, which have smaller context windows, may need lot more description to determine the appropriate tool call based on the user's query. And usually users' queries are pretty non-descriptive. Like for example, hey, send this Slack message to Tamil in my account saying I will be late for the webinar by 10 minutes. Now, there is a lot of context that the LLM need to figure out. Who is Tamil? What is Slack account? Who are you? How do I construct this message in a way that that tool definition would understand? So all of this depends on the model that is having this intelligence to determine what is the user's query, what is the context, what are the tools that are there in the context, and which tool is appropriate to solve this particular job. And more often than not, it's not necessarily just one tool. It could be different tools that the LLM needs to chain in order to get the desired results. So always test your tool descriptions and tool schemas across different models and making sure that it is working really well, and then constantly iterate. And you can also introduce some sort of an RL, reinforcement learning, based on the patterns that you're observing in your monitoring windows based on how the tool calls are getting executed and things like that. But the least that you should do is eval and test your tool descriptions for at least some of the popular models so that your customers get the best output of the MCP servers that you're offering to your customers. So I spoke about MCP servers. You are building your MCP servers. Why should you build your MCP servers? How should you build your MCP servers? I also spoke about security authentication a little bit and how MCP as a protocol updated their spec with OAuth 2.1 as a mandatory requirement if you are building authorization layer for your MCP servers. So I just want to give you a simple workflow of how it looks like and how can you implement this complex looking workflow with Scalekit in just 4 steps, and I'll take you through the demo. Again, this workflow seems daunting, but I'll break it out for you. There's always browser in the context because there is OAuth. Now, whenever an MCP client wants to establish a secure communication with an MCP server, the first thing that will make is, hey, first tell me all the tools that you have, which is called as, actually, even before that, there is an connection establishment. But then for the sake of this conversation, let's say it asks for, hey, what are the capabilities of your MCP server? Give me all the tools that you have. The MCP server should respond with all the tools that it can so that the MCP client or the MCP host knows how to use this MCP server or when to use this MCP server via the LLM that they're working with. But if your remote MCP server is OAuth protected, what you would do is, hey, you are not yet authorized to talk to me. I am an OAuth protected resource. First, get a token from my authorization server and then present the token in all your communications with me so that I can work with you effectively. So this is called as secure exchange of metadata information between an MCP client and MCP server. So as part of the error message, the MCP server also points to what is called as well-known protected resource metadata that the MCP client can just do a fetch of the JSON metadata and then look up all the information that it needs to get a token from the authorization server of the MCP server. So once MCP client fetches this OAuth protected resource metadata, it will go to authorization server endpoint that is mentioned in the JSON, and it will take the user to that authorization server, initiate an OAuth workflow, get an access token from the authorization server, and then use that access token for all its communications with that particular MCP server. That is a gist of high level overview of the workflow. Now, to be able to build that successfully, What we did was we crunched it down to 4 simple steps so that you don't have to build an entire OAuth layer for your MCP servers, and then you can focus on building the business logic for your MCP server and then leave the authentication and security to Scalekit. So what are the steps? First step is you log into your Scalekit dashboard and then you register your MCP server details. Like, hey, this is my MCP server name. This is my MCP server endpoint, and these are the scopes that I want to offer so that the MCP client would know what scopes it needs to get access for. And that's it. The second is, as part of you registering your MCP server in Scalekit dashboard, we also give you a metadata JSON that, like I told you earlier, you need to share with the MCP client so that the MCP client knows how to talk to your authorization server and get a token. So you would just implement get at a well-known OAuth protected resource endpoint, and then supply the JSON that we give you. You can copy paste it in your code. It's hardly 4-5 lines of JSON that you need to do. And then MCP client will do whatever it needs to do to get an access token. All you need to do is you make sure that every incoming request from any MCP client that you get has a valid JWT2 token, and to determine which user is actually making or accessing my MCP server and appropriately resolve requests based on the incoming request or which tool to be executed and things like that. And then optionally, if you want to enforce fine-grained scopes, you can also check whether the user has granted that MCP client the appropriate scopes for that particular request. For example, if you are the developer who is building Gmail, you may have a lot of scopes called read email, create drafts, update email, delete email, etc. But the user may have given access to that MCP client only to read emails, but not to create emails. So when the MCP client is making a request with the appropriate access token, as an MCP server, it's your responsibility to make sure that that access token has the appropriate scopes to execute the appropriate tools. Great. Whatever 4 steps that I briefly described, Akshay, who is the lead software engineer in our team, will show how to actually put together the whole thing, building a remote MCP server, adding auth layer to it, and how easy it is to overall put together a secure and authorized MCP server. Akshay, over to you.
Hey, thanks, Ravi. I'll share my screen. I think, Ravi, you might have to stop the share. All right, perfect. So we'll be going through the 4 steps. Let me collapse this. Yep. I'm logged into Scalekit's my workspace. It's called a greeting workspace. The app that we are going to secure using Scalekit is a simple greeting MCP server, which has one tool called greet user, and the client, like when you invoke the tool, you just give the name of the user who needs to be greeted, and it echoes that. So the first step is to register the MCP server. When I think about registering the MCP server, the first thing that comes to my mind is about the registration of scopes. I need to make Scalekit aware that what scopes I am going to use in the MCP server for fine-grained control. So here I have created a scope called user read and the description. This description will be used during the process of authorization when the user will be presented with a consent page, and the user will be able to see what permission is being given. So the scope addition can be done using add permissions. Here I've already done that. As part of registration, we can add a MCP server from here. And in the interest of time, I've already created the MCP server, which has the server name as greeting server. This is the resource identifier. I'm running it on my local machine, and during the time of token validation, this particular resource identifier will be used. I want to make sure my MCP server allows dynamic client registration so that all the MCP clients can register a client ID and use it whenever the authorization is needed with a 60-minute of token lifetime. There are 2 options. We can use Scalekit's own authentication service, or you can bring your own authentication service. So for this demo purpose, I'm going to use Scalekit's authentication service. And yep, so once we create the server, this is the step number 2 that we saw in the previous slide, that our MCP server should host this resource metadata on this endpoint. So I'm going to copy this, and I have the project here. Let me minify and paste it here. I need the MCP server ID. Then I would need the Scalekit's client ID and client secret. for which I'll go to settings, I'll get the client ID, the environment URL, and I'll generate a new client secret. All right. So by the way, this demo app is the MCP demo app is present for everyone. We'll share the link. Right. So this is my main file, main.ts. And what happens over here is we create an Express server. And the first thing, as I said, is we need to expose a well-known OAuth protected resource endpoint. And this is where it gets served from. We need a middleware that does the token validation. So I'll go into that. And this is the part where the token validation is done using Scalekit's SDK. In terms of the fine-grained control of scopes for a particular tool, this is where we pass the token and the required scopes to be validated whenever we get a tool call. Going back to the main.ts, we simply set up transport, HTTP streamable, and then we register the tools. In this case, I have a greeting tool. And when I go to the definition of greet user, it has a name, a description. This description will help the model understand when to invoke this tool and the required scopes needed, which we have made already Scalekit aware of. And yeah, that's pretty much it. This is all the input that it needs is a name. So I'm going to use VS Code itself to connect to the server. Let me run it. Right, our server is running. I'll go to mcp.json. So this is all the MCP client needs to connect servers, the server name, URL, and the type. So I'll click on start. It asks me to initiate the authentication. Goes to Scalekit and let me log in with the OTP. And this is the consent screen that I was talking about, that the server, as part of the protected resource metadata, already made the client aware that it would need user read, and that's why user read scope came through during the authorization process. And it says reading basic information of the users. I'm gonna click on authorize, and it comes back to the MCP client. So I'll put a prompt something like, I have a new user, John. Can you greet him? So it identified which tool it needs to invoke, and it got the response. In this case, it's a simple text response. It could be a structured output schema, and yep, it interpreted it and gave the final response. So yep, using Scalekit's auth solution, this is how we can protect any MCP server.
Thanks, Akshay. That's brilliant. So just to recap, when you're building an MCP server, all you need to do is make sure that you're advertising to any MCP client that wants to communicate with your MCP server that you are an OAuth protected resource. And the way you would broadcast that information is by implementing the well-known OAuth protected resource endpoint. And MCP clients that support OAuth-based authorization know how to fetch that metadata information, parse that metadata information, interpret how to get an OAuth token based on the metadata information that is present, and then take the user to complete the OAuth workflow. Basically, open a browser, go to the appropriate authorization server endpoint, get an access token, and then use that access token in its subsequent communication with the MCP server. That's what you saw just now. And all you had to do was sign up to Scalekit, register an MCP server, copy paste the metadata JSON that you have, and implement your OAuth protected MCP server in just a few steps. Yeah, I think that's the demo. That's what we wanted to share. We are happy to take any questions if you have anything related to MCP servers, authentication, authorization, etc. I see one question that's coming from Stephen. Can you say a little bit more about how to eval MCP servers against different models? How do you do it? What I mean by that is we actually eval the tool descriptions, not the MCP servers itself. Why is that important? So in the demo, Akshay was writing a query that says, I have a new user called John. Can you greet him? Now, what is that MCP host, in this case, VS Code, doing is it is taking that context and supplying that to the LLM to say, hey, this is the context of the user's query, and these are all the MCP tools that I have. Now, LLM need to figure out that this is the appropriate tool to be invoked. Now, how does it do that? It does that based on what is the context that is supplied to it, based on tool description, what are the input parameters for the tool, and for LLMs to make effective judgment to determine which tool to be invoked is when you need to is dependent on how effectively you wrote your tool description or input schema. That is what you need to eval against different models, right? Because LLMs are using that information to judge what is the appropriate tool call to be made, what is the first tool call, second tool call, third tool call to solve a user's query. When you are looking at eval, what we have done is we took a use case and we supplied different tools in the context for that use case, and then evaluated is the model that we are using picking the appropriate tool call based on what we know as a preconceived context, right? We would supply hundreds of different user queries for the same job with the same tool calls, and then we look at what is the predictability ratio of LLM picking the appropriate tool call based on the incoming query and the tool schema that we are supplying. And we constantly iterate on the tool summary, tool description, and the tool input parameter schema definitions so that we keep improving the percentage of right tool selection over a period of time. That's what we mean by using evals to improve your tool descriptions to help your customers implement better AI agents on top of your MCP servers. I see a few other questions from Sushant. Will you support authentication from AWS Cognito? Yes, we do. Scalekit also has a human authentication platform. Either you can use that, but we can also work with any of your existing human authentication systems that you're working with. It can be Azure Entra ID or AWS Cognito or Firebase, etc., etc. The login screen and custom screen, of course, they can be customized using your own branding, using your own logo, and using your own parameters. Basically, anything that you see that is visible to your customers can be customized to your branding, including the URL, which can be CNAMEd to something like mcp.yourcompany.com, for example, or mcp.auth.yourcompany.com. The whole idea is to give authorization as a framework to your customers, and your customers should never have to know that Scalekit is powering the whole security and authentication layer for your MCP servers. Hope that answers your question, Sushant. Ronak has a question. I think it's a very, very important question to address. I think the question revolves around the quantity of MCP servers and the number of tools that are configured as part of each of these MCP servers. I think the question, if I interpret it, Ronak, feel free to correct me. I have an agentic use case, or I have an MCP host that I'm configuring hundreds of MCP servers, and each of these MCP server can have tens of tools. So technically, that MCP host has to work with 1,000 tools in context at all times. So for example, if I've configured hundreds of MCP servers in the Claude desktop that I use, and each of these MCP servers has 10 tools, that means every time I ask Claude a question, it has to supply all the tools that it has in its configuration and all the tool descriptions, all the input schemas as part of the context to the LLM that it is working with to determine what should be done to resolve this user's query. So what we recommended to some of our customers who are building agentic access to their applications is curate your MCP servers in such a way, or curate the tools that the agent needs to work with in such a way that you are not overloading all the tools that are possibly applicable for that MCP server as part of every agentic execution. Let's say you are building an agent that summarizes emails. It doesn't need a Slack MCP server. All it needs is fetch emails tool of the Gmail server. And most of these agentic frameworks like LangChain or even OpenAI Responses API takes in, hey, you can also filter, even the MCP server supports hundreds of tools. You can actually use only these tools as part of this agentic workflow. So you can limit the number of tools that you want to pass in that context to the LLM so that LLMs have a better chance of selecting the appropriate tool for that particular job that is being done. One thing that you need to constantly think about is, what is the context window of the model that I'm working with? And what are the most appropriate MCP servers or the tools that I need to supply to that particular model so that the results of that agentic execution is probably better and probably successful. And the number one rule that you need to think of is reduce the context window, limit the number of tools that you're passing to the LLM so that it can do a job effectively more often than not. Hope that answers your question, Ronak. Any other questions? Please feel free to drop in. I know, Ronak, you asked a follow-up question. I have a SaaS platform, want to make a native. In that case, I can't compromise with MCP servers. I'm sorry, Ronak, I'm not able to understand the question. Would you mind rephrasing it? I'll move on to the next question. Dana has asked a question. What are the vulnerabilities you have predicted for this framework? Again, Dana, assuming you are asking why is OAuth needed for this MCP server, or what sort of vulnerabilities does OAuth for MCP server solve? I'm assuming it's the later. Again, the whole context of protecting your MCP servers is to make sure that the agents or the MCP hosts that are using your MCP servers can reliably and securely communicate with your MCP server. So one of the two things that you need to think of is agents are autonomous in nature. They don't do predictable actions. That means you would want to restrict the scope of each of these agents that can do on behalf of the user in your MCP server. And OAuth as a framework gives the ability for the user to let the MCP client consent to only those actions that the user is comfortable with, even though the MCP server can handle tens of different of capabilities. The point number one, user is always in control of what capabilities of that MCP server does he want to give access to that particular MCP client that he is working with. The second thing is, of course, the token longevity itself. By default, all the access tokens that we supply to the MCP clients that are requesting for an access token are short-lived. Again, this is to make sure that the agents don't outlive the purpose that they're meant to solve for, because the user would have configured an MCP server to get a job done and then forgot that that even exists after a day. But with OAuth-based framework that we've built, the tokens that we issue with the consent of a user to the MCP client is short-lived by nature, and they can, of course, seek additional access tokens, but it always is in the context of the user granting that additional time period for that particular job that the user wants the MCP clients to do. So the fundamental thing that you need to think of is, hey, how do I not give perennial access to agents to act on behalf of the user? Problem number one, the OAuth framework comes with a beautiful solution for that in the context of access tokens, refresh tokens, and all that. So all the good bits of OAuth 2.1 come by default using the Scalekit platform. Those are the things that we were able to help with by protecting the MCP server via OAuth 2.1 layer. I hope that answers your question then. Any other questions? What are your recommendations to mitigate or prevent? Yeah, I think that's a great question, Stephen. Again, we're still very, very early in this Wild West journey. There are a lot of security tools that are promising to set up guardrails against incoming MCP requests to make sure that the requests are actually genuine. I think the combination of having a secure OAuth layer and the other MCP tool poisoning security solutions on top of your MCP servers, I think the combination of these would be a solution. I know personally of a few startups that are operating in this area. I can share those recommendations with you. I have not personally worked with them, but then I've interacted with the founders of these companies, and they seem to be doing a good job, and they seem to know what they're doing. Yeah, that is indeed the tricky bit, Stephen. All right. Thank you so much, guys, for attending and asking your questions. This has been great, and some of the questions were really, really beautiful. Thank you so much for asking these questions. Finally, we have a form if you're interested to try out our auth for MCP solution, or if you want to have a further subsequent conversations with us, please fill in that form so that we can work with you. We can help you get onboarded, especially for some of the things that you're asking about. If you can work with AWS Cognito, if you can work with Azure Entra ID, etc., we can work with you and then figure out the effective solution to add OAuth layer for your MCP servers effectively. Thank you so much once again. Bye.